All right, so the base of the solid is right here in the shaded area. It's bounded by these graphs, F and G. The cross sections perpendicular to the x-axis, are semicircles. Let's write down our steps. Got one word. I got one word for every step. First, our integral. It's perpendicular to what? X-axis. That's how you know. Okay, let's see. We're going to integral. We need a of x. That's what we need. An a of x dx. Okay, so do you guys know what our lower bound and upper bound are? Oh, it says A and B. Shoot. A and B. That means we have to find them. Let's go ahead and find those because usually that's not that bad. Okay. Gotta find them. Oh, we just have to set it up. Gotcha. I mean, you got me. Okay, sorry. Area formula. What's my area formula? What's my cross section here? It goes from here to here. All right. How do we find that? Formula. Okay, and here's my semicircle. Oh, look at that nice semicircle. It's like, it's popping off the page. Okay. Semicircles. Okay, so what's the formula for a semicircle? Half pi r squared. Right? Okay, we good? Okay, those are supposed to be the easy steps. Now you guys ready for the hard step? No, thank you. Okay. So here's the thing. My radius is this. Okay, it's half of the diameter. But how would you find the diameter on this? The diameter is endpoints right there and right there. If you actually knew this number, let's pretend this number is 10 and this number is 6. What's the length of my diameter? Like we're pretending this is 6 and this is 10. What is my diameter? Yeah, it would be 10 minus 6, right? But we don't know this and we don't know this, so we're going to call this G and we're going to call this F. So what would I have to write to find my diameter? My diameter would be, oh man, I hope you guys already said this in your head. G minus F, that's my diameter. But I don't need diameter, I need a radius. Unless you have the formula with diameter in it, which we don't. Oh yeah, just divide it by 2. So we have, okay, first of all, it's an area function of x. We need to know that. I'm going to write this up here. So we have area function of x, and we're plugging in. Instead of r, we're taking r out. Let's clean this up. Let's go half of pi, and then we have our r, and then squared. Our r is g minus f divided by 2. Right? Are we all good? Hey, easy peasy, right? Easy peasy. No? Okay. I'm not gonna simplify this. Well, I guess I could and still leave the g minus f, because I could square the denominator and it'd be 4, and this would be an 8. So here's another way to write it. We could say square root of 8. And then g minus f squared. They're the same thing, though. I don't know. I haven't looked at the answers yet. I know you guys have, but I haven't looked at the answers yet. So let's just let's set up our integral that we would have to integrate. That's our last step, but we don't have to solve it. So we're going to go from a to b, and our a of x is going to be pi over 2 g minus f divided by 2 squared with respect to x. Is our answer anywhere?
D, but it was
Oh, they did it. They took out the 2 squared. Okay. Do you guys want to see how that's done, or are you guys good with it? Okay, so you can go g minus f squared over 2 squared. You can do it like that. And so this 2 squared is 4, so 4 times 2 is 8. And so not that. And we could take the scalar and put them out here, and that's exactly what they did. So it's not this one, not this one. It is this one right there. I think, yeah, they went G minus F. I saw the none above, and I was like, ooh, I better check it.